Hi, this is Tony Northrop for Train Signal, and in this video lesson for the SSCP certification exam, I'm going to describe centralized authentication as a concept and many different centralized authentication mechanisms that you might run into in the real world. Now let's talk about centralized and decentralized authentication, and we both use examples of these every single day. Centralized authentication is really common in enterprises, and our daily life. Medium and large organizations all use centralized authentication for their accounts. One of the most common examples of this is Active Directory, but any sort of like Kerberos or ticket-based system pretty much allows this to happen too. When you type in your username and password, your local computer or device sends your credentials off to a central server that then determines whether you can be authenticated or not. So you're not authenticated locally. You require some network access to get authenticated. Because it's in a central place, just about everything centralized is easier to manage. All the usernames and passwords are in one place, so the administrators can harden that server and make sure that it can't easily get hacked into. They can also easily back it up and restore it if something goes wrong. So some common examples of centralized authentication are Active Directory, which is popular in enterprises. That's a Microsoft product. Facebook Connect, which is popular with consumers. I log into lots of websites now using my Facebook account, and it's nice for Facebook to do this. Well, it's nice. I know they're tracking what I do and making some money off of that, but frankly, I'd rather they make a few coins off of me logging into different websites than me having to remember another username and password everywhere. I also feel like the security is better because the websites that I log into with Facebook Connect, they don't have to know my username and password. They know who I am, but they don't store a copy of my password. Only Facebook does, and maybe I don't trust Facebook, maybe I do, but at least it's fewer people that I'm trusting with my password. Microsoft accounts have a very similar model to Facebook Connect. I only bring it up because Windows 8 allows you to log in with a Microsoft account, formerly known as a Windows Live account, and when you log onto your local computer, it actually goes to contact Microsoft central servers. And so why would you want this? If you're logging onto a local computer, why would you not just log into a local account? Well, the Microsoft accounts are a little bit easier to manage. So if I forget my password on a computer where my account is stored locally, I'm basically out of luck. I need to reformat my drive or something. I won't be able to get back to my account. But with a Microsoft account, I can go onto their website and enter in, my mother's maiden name and my dog's name, my first street name, and I can reset my password. So they have different ways to manage your account. It also allows me to log on to each of my 10 different PCs at home, whatever number I have, using the same username and password without having to manually synchronize them. Things like your debit card pins are centralized at your bank's servers, and nowadays when you buy a concert ticket and they put a little barcode on there that the ticket taker scans, that's going back to a central server, and it's just making sure that the code is legit and hasn't previously been used. That's a form of centralized authentication that you probably see in your daily life. One of the challenges with centralized authentication is that it needs to contact a central server to verify your credentials. So what happens when you don't have internet access? I know you're probably in a cold sweat anyway because you can't check Facebook statuses, right? I hate being offline too. But you still want to be able to log on to your local device even when it can't connect to an authentication server. So there's a mechanism called offline authentication using cached credentials, and basically it'll store a hashed copy of your password, and if it can't connect to the authentication server, then it will say, okay, I can't connect to the authentication server, but this guy used the same password last time, so he's probably okay. As an administrator, you usually have the ability to turn that on or off, and it can be quite inconvenient if you turn off offline authentication, but it does improve security. The opposite of centralized authentication is decentralized authentication. You use decentralized authentication every time you type a PIN into your phone to unlock it. You pretty much do that so your buddies won't go on your Facebook and make an embarrassing status, right? Well, it's not going off to some central server to do this typically. It's just storing the password somewhere inside the device and letting you log in. It's also how you logged in with every personal PC at home, at least before Windows 8. You just had a local username and password, and that's what you logged in with. And if you had 10 PCs at home, you probably made an account on each one of them. And I bet you use the same username and password on every one of them, but what happens when you had to change your password? Well, you'd have to go log on to every single PC and change it, right? it's hard to manage. And that works okay for small organizations. If you have 5 people in your company, you can just create an account for each one of them on every different computer, and it's not a big deal. When they change your passwords, it's a little bit of a pain, but it's not that bad. And it's not bad at all if it's just your one phone. It would be no more work than centralized administration, right? Old concert tickets worked like this too. You would just hand the ticket to the guy, and he would look at it, and he would try to make sure that it wasn't just forged, and then he'd let you through. In other words, the ticket taker was the entire authentication mechanism. It was decentralized because they probably had 10 different ticket takers, and it probably wasn't the same guy who printed out your ticket. So in the new concert model, they scan it, and it goes back to a server to make sure that the ticket number is valid. In the old decentralized model, you had to trust that ticket taker. And you couldn't always, right? Sometimes they might let their buddies through. Sometimes they might not recognize a forge and they would let it through. Decentralized authentication provides for easy offline authentication because it's stored in the local device. So it doesn't matter if it's online or offline. I can always log on to my local account on my PC or unlock my phone with my PIN number. I'll tell you a quick story about centralized and decentralized authentication. I was in New York City a couple of months ago, and I bought a ticket for a movie off of a guy. And I'm a fairly security savvy guy, right? I was trying to buy the ticket from a kiosk, an automated machine that they had set up, and it wasn't working right. And so a guy who was speaking very formally said that the machine wasn't working, but he would sell me the tickets directly. I know, right? I believed him. He looked legit. So I bought the tickets from him, and I went and got in line for the movie, and they had a centralized authentication mechanism. They had a little laser scanner that would scan the barcode on every ticket. And the lady's scanning everybody, and everything's going through fine. It's like scan, beep, scan, beep. So she scans, and then it's beep. It's like a buzz. And she scans it again, it's like a buzz, and it's like, I don't know why it's not reading your ticket. And she says, oh man, and it's like a weird color, right? This ticket looks weird. And she's like, all right, go ahead. So this is a little bit of a combination of centralized authentication and decentralized authentication. They had this really nice centralized authentication mechanism set up, but ultimately she exercised her right of decentralized authentication mechanism, even though centralized authentication completely failed, and I'm pretty sure in hindsight I bought a fake ticket from a guy. The decentralized authentication authority put upon the ticket taker, she decided just to let me pass with my forged ticket. One of the benefits of centralized authentication is single sign-on. Now, I talked earlier about how you probably have different usernames and passwords for hundreds of different websites. That's not single sign-on. That's having separate credentials for every single resource you need to access, and it's a total pain, right? Because you forget your username and you forget your password, and everything gets jumbled up, and if you go to change your password, you'd have to go log on to each different resource and change your password. Single sign-on allows you to use a single set of credentials to access multiple resources, usually throughout an organization. It minimizes the number of passwords that users need to memorize because you just know your username and password, and it's the same for the printer, as for the file server, as for the accounting website. The downside to single sign-on is that if somebody gets your username and password, well, they can just access everything, right? They just suddenly have free reign. Still, it's generally considered much more secure than not using single sign-on. And as a result, all these different open standard protocols have popped up over many decades. XTACACS, TACACS+, Radius, Kerberos, X509. I'll cover some of these in more detail right now. First up, Kerberos. It's probably the most popular one around currently because it's what's implemented by Microsoft Active Directory and several different Unix-based centralized authentication mechanisms. Well, it's centralized authentication, and it provides a single sign-on architecture, so you can use a single set of credentials to access many different resources throughout your organization. Another trait of it is that it supports mutual authentication. That means that the server authenticates the client, and the client authenticates the server. Why do you want mutual authentication? Well, you can't trust the server that you're accessing. Some people think you can because, well, you're going to the server, right? But it's easy to impersonate a server. And that's a common form of attack known as a man-in-the-middle attack. You can impersonate a server, gather somebody's credentials, and forward them on to the legit server, and then you get to capture all the communications going back and forth. Mutual authentication would usually break that, would allow the client to recognize that the server was not legit. The way Kerberos works is when you authenticate, it gives you a token, a ticket. And you can use that token to go and authenticate yourself to many different resources. And the token basically says, this user is a legit user. This is their username. It's just authentication. It doesn't say they're allowed to access file servers. That's up to the file servers to decide. They do the authorization. Kerberos just does the authentication. So the user will, instead of just going to a file server and saying, I'm Tony Northrup, I can say, I'm Tony Northrup, and here's my token proving that I'm Tony Northrup. It's like holding up your ID. The file server can then look me up and say, okay, Tony Northrup, you're a legit user. Or it could say, I agree that you are Tony Northrup. You've proved that, but you still don't have access to this resource. So this is an example where you need to understand the important difference between authentication and authorization, because Kerberos handles authentication, but not authorization. So these Kerberos tokens have a limited time on them, because after all, it hands me this token saying, I really am Tony Northrup, but it doesn't want me to use that forever. If it did, well, I could leave the company and they could disable my account, but I would still be able to use this token indefinitely. So they have a limited time span. And that means that the resource servers and the client computers and the Kerberos server all have to agree on what time it is. Because if I'm accessing a file server that thinks it's next week, well, it's going to look at my ticket and be like, this ticket was printed a week ago. I can no longer accept it. It's expired. And that's going to cause a problem of a false negative. It can also cause a false positive. Imagine that I have a ticket from last week and I've since left the company. My ticket should have expired already, but if a file server's clock is back by a week, it's still going to think my ticket is valid. So you need to have all your clocks synchronized in the organization, and that's pretty easy. There's this protocol called NNTP that allows different computers in an organization to synchronize their time. And you know what, in Active Directory environments would use Kerberos, it happens automatically anyway. Kerberos, the protocol isn't nearly as exciting as a three-headed dog, but it does have three heads, and hence the name Kerberos. There's the KDC, the Key Distribution Center, the Authentication Server, AS, and the Ticket Granting Server, TGS, and I'll go over these a little bit more in a minute. I also want you to be familiar with Sesame. Sesame is a protocol very similar to Kerberos, very, very similar. In fact, it supports Kerberos APIs. So Kerberos clients could authenticate to a Sesame server, but it works similarly. And just remember, if you happen to see Sesame come up on the exam, it's basically an updated version of Kerberos, which doesn't happen to be used quite as often nowadays in the real world. So here we can walk through the Kerberos authentication process. Over on the left there, you see the client, which in Kerberos terms is the principal. And on the right, you see the AS, the KDC, and the TGS. The bottom right is the application server. That's the server. It could be a file server. That's got what we want to access. That is the object, whereas the principal on the left is the subject. In the first step, the principal contacts the authentication server and requests a ticket granting ticket. This is basically saying, hey, do I have the right to go to the ticket granting service? And the authentication server, hopefully, says, yes, all right, you may approach the ticket granting service. Think of that like taking a number at the deli. Once you have a number, then you have the right to go up to the guy at the deli, right? Well, that number is your ticket granting ticket. This terminology is terribly confusing, I'm afraid, but I do want you to be familiar with it for the exam. So the subject, the principal, uses their TGT to request a service ticket from the ticket granting server. And if everything looks okay, if the guy's legit, the ticket granting server responds with a service ticket. That's your token. That's what you can use to actually authenticate. So in the next step, the principal, the user, the subject, can approach the object, the resource server, and say, look, I have a service ticket, let me access stuff. And there's a little bit more to it than that. It's fairly complex, but at a high level, that's how things unfold. And I just want you to understand that for Kerberos, there's these ticket granting services and authentication servers, and you end up with you need a ticket granting ticket before you can go to the TGS, and then it'll respond with a service ticket or a token which you use to actually authenticate. Remember that for the exam. Another common centralized authentication mechanism is RADIUS, which stands for Remote Authentication Dial-In User Service. And RADIUS has a long, long history going back to the dial-up days. Back in the olden days, like let's say the early 90s when everybody accessed the internet through dial-up, well, you would connect into this huge modem bank with hundreds and hundreds of modems. And it's not like each modem had every single user's username and password in it. No, they all needed to talk to a single centralized database. So they used this protocol called RADIUS. And as a result, RADIUS provides not just authentication, but also authorization and accounting because it fit that scenario. Like ISPs would charge you for how long you were connected, so they needed these extra accounting protocols in there. And nowadays, most people are using RADIUS for things like network access and VPNs, basically non-metered connections. So the accounting part isn't used all that much anymore, but the authentication and authorization are still used. RADIUS is this really simple protocol. It really doesn't even have any kind of encryption security built into it. Like you could type RADIUS commands into a telnet window and authenticate yourself if you really wanted to. But basically RADIUS allows dozens or hundreds of different dial-up servers, VPN servers, networking equipment to check the credentials of devices that want access against a central server. And because it's old and open and standardized, it works with just about everything. Unix machines, all sorts of VPN servers, Active Directory. In other words, you can log into a dial-in server or a hardware VPN device and go through a RADIUS server to authenticate to a Microsoft Active Directory domain controller. That's the power of RADIUS. It can connect back to just about any type of authentication server, and it can connect from just about any type of network access device. It's that middleman. As you see at the bottom there, it uses UDP ports 1812 and 1813. The older standards were 1645 and 1646, and you know, I didn't see any port numbers on the exam, but it wouldn't hurt to know them. So let's walk through the RADIUS authentication process quickly. The user initiates a connection to the network access server. That can be a dial-up server, it can be a VPN server, or it could be a physical wired network server supporting 802.1x, which authenticates wired network connections. It could also be a wireless access point, 802.11g, 802.11n, whatever. All these devices are network access servers. The network access server says, oh, I noticed you want in. Why don't you send me over some credentials? And the user gives them usually a username and password, though it's flexible. It could be something different. The network access server, wireless access point, VPN server, dial-up server, whatever it is, sends a request to the RADIUS server. And what you don't see on the diagram is the RADIUS server then probably sends a request to a Kerberos server or a domain controller or something else to actually authenticate the user. But then the RADIUS server responds to the network access server, and the network access server says, hey, you're legit, welcome to the network. Now let's talk about some of the risks of RADIUS. Now, as I mentioned earlier, RADIUS communications are not encrypted in any way that's inherent in the protocol, but they can be encrypted by IPsec or physically encrypted by specialized devices. For example, if you use a fiber optic cable, well, it's pretty hard to sniff that. So you can control that risk, but if you don't put some other form of authentication in there, well, you can just connect a sniffing device and see everybody's usernames and passwords going through. RADIUS is also vulnerable to spoofing. You could intercept communications going to the RADIUS server and just start replying yes to everybody, or you could just start capturing everybody's passwords. But that's really true of any type of authentication mechanism. They're vulnerable to denial of service attacks. as are every centralized authentication mechanism. You can just start sending a ton of authentication requests to a Radius server or Kerberos server, and eventually they're going to get bogged down. Denial of service attacks can be successful anytime it's easier for a client to send a request than it is for the server to process that request. And in the case of authentication requests, well, the server has to do a bit of processing, hashing the password, maybe sending a request to a different server. The server is doing more work than the client is to submit the request, thereby making it vulnerable to a denial of service attack. Radius also doesn't implement any sort of one-time password system, making it vulnerable to replay attacks. That means you can capture somebody's password and then just replay it to log on as them later. Radius uses the MD5 cryptographic algorithm, and there are some known vulnerabilities with that, but honestly, Radius is implemented all over the world, and nowadays the way it's actually implemented pretty much limits these risks. Here are some of the ways you can mitigate it. You can harden the Radius server, which means host-based firewalls. You can use things like IPsec and SSL to encrypt it. And you can use unique shared secrets for every Radius server. Radius, even though it's a really old authentication mechanism, supports these shared secrets between the NAS, for example, the VPN or the dial-up server, and the Radius server. Basically, it's a password, and they each share that password, and they won't authenticate unless they each know it. Now, that's not terribly manageable. You literally go and you type that shared password into the VPN server or the dial-up server, but it is the way Radius allows authenticating both the network server and the Radius server. Now let's talk about TACACS Plus, Terminal Access Controller, Access Control System Plus. It's a new version of TACACS, which is TACACS Plus without the plus, right? Makes sense. It's responsible for authentication, authorization, and accounting. Just like Radius, it does a lot of the same stuff. It encrypts not just the user passwords, but the entire payload. So it's a little more advanced than Radius in that it provides that inherent encryption. Realistically, it's better. Hasn't necessarily become as popular just because we've learned to layer on other security on top of Radius, and every device in the world supports Radius. By default, it uses TCP port 49, which, because it's TCP, it's connection-oriented as opposed to the connectionless UDP communications that Radius uses. TACACS Plus is a protocol created by Cisco, so it's commonly used in Cisco equipment, not commonly used by other types of equipment. Honestly, Cisco equipment uses Radius, so a lot of people still end up using Radius. Because Cisco makes a ton of routers, it works well with their router management software and with terminal services, which provide remote access to devices. TACACS Plus has a couple of weaknesses. The accounting information is still sent in clear text, but not the authentication information. The accounting information is just controlling how long people are logged in and such. It also has limited integrity checking, which basically means that people have figured out how to compromise the integrity of it. But it's better than Radius, so use it if you can. I also want you to be familiar with TACACS, without the plus, and XTACACS. And these are both older versions of TACACS Plus. They shouldn't be used on newer systems. They're pretty much outdated. I don't know of any servers out there still using TACACS or XTACACS, but they were used for many years. TACACS had authentication and authorization combined in a single process rather than separated out, which made it a little less flexible. It used connectionless UDP. Remember, TACACS Plus uses connection-oriented TCP. It didn't support any sort of accounting, and it didn't support multi-factor authentication, so it was always basically username, password. XTACACS, extended TACACS, so it's a little bit newer, but older than the more common TACACS Plus. It did separate out authentication and authorization. It had a less granular accounting process than TACACS Plus, but it was still better than TACACS, which didn't offer accounting at all. And like TACACS, and unlike TACACS Plus, it used connectionless UDP. Now let's talk about LDAP, the Lightweight Directory Access Protocol. LDAP is not an authentication service. These other services I've been talking about authenticated you. They would determine whether you were allowed to access resources. LDAP is something I want you to be familiar with for the exam, and I think this is where it fits into the video lessons the best. But let's make it clear, it's not an authentication service like Radius or TACACS or Kerberos. It's a directory service. It allows you to query and update devices on the network. So you can find a printer that's near you. Or you could find the username of your buddy down the hallway so that you could share a file with him. For example, if you knew his last name, you might have to look it up to find his actual username so you could assign the user the privileges to the file. It's based on an older standard called X500, which is basically a set of objects and all their attributes. As we'll see on the next slide, it's organized in a hierarchical structure. If you're familiar with Active Directory, you are already familiar with the LDAP structure, even though you might not necessarily talk about it as LDAP. Besides Active Directory, Novell's old eDirectory system used it. Nobody uses Novell anymore though, right? Okay, some people use Novell, no offense. LDAP uses TCP and UDP port 389. Again, I don't expect that the exam is going to test you on specific port numbers, but I think port numbers are one of those things that kind of make you a little cool to know. Like you can throw it out and act like you know what you're talking about, right? So if you're the type who's good at memorizing numbers, file these port numbers away for later use. So when I was talking about object names in LDAP and the hierarchical structure of them, this is an example using Active Directory. If you ever manage a Microsoft network, you'll recognize that window in the upper right corner. And if you don't, that's okay too, because it's just an example of an implementation with LDAP. And we can see at the top of this hierarchy, we have a domain called globalmantics.local. And this is identified by this top level here. Now, there's an organizational unit that we're digging into. These are all organizational units, but here we're digging into an organizational unit called locations. And this works just like a folder on a file system. The OU doesn't do anything in particular except allow you to organize it. Heck, it's named perfectly, right? Organizational unit. And within locations, we have separate OUs for Chicago and New York. And in the Microsoft implementation here, you can see those mapped to these little folder-looking things. And each of these separate location organizational units within it has more organizational units for computers and users. And if you wanted to drill into particular usernames, well, you'd have to go all the way to the bottom here. For example, here are common names, CNs, for Mary and Tony. Now, the way LDAP names uniquely identify an object is basically by listing the type of property and the value for the property in order from most specific to least specific. So DN here stands for a distinguished name. And then we have common name, CN equals Tony, OU users, OU Chicago, OU locations, and DC globalmantics, and then DC local. And this allows you to uniquely identify an object wherever it is in the directory. And yes, these names can get really, really long. This is not a particularly long example for a name. So here are a couple of theoretical LDAP security concerns. Realistically, the implementations tend to deal with these in a very strong way. There's no software I know of that uses LDAP and has some huge security hole that you can get through. They've protected it well, but LDAP as a protocol doesn't really offer any security at all. That just means that you use IPsec and firewalls and hardening to protect it. However, it does store very confidential data. It has every user in your organization and probably which groups that they're in and where they're physically located. This is not stuff that you want just anybody to see. So as I was saying, you mitigate these by providing security in other ways, and this is usually turned on by default whenever you install an LDAP implementation. So if you go and install Active Directory, well, it'll use LDAP, but then it will automatically configure all this security, and this is true of other LDAP implementations too. LDAP uses ports 389 and 636 if it's secured using SSL, which is a separate protocol called LDAP-S. So just make sure outside requests aren't allowed in on those ports, and the firewall will help protect it. This is Tony Northrup for Train Signal, and thanks so much for watching this video lesson.